So guys, we'll start with the upthrust numericals. Okay, so first of all, remember there are many numericals in your textbook, but you actually don't have all of them in the portion. So I'll explain you all the one which are actually you have only the simple numericals in your portion. So I'll explain you all the one which are more important from the exam point of view first. So let's discuss the formulas first, all the formulas that you have in this chapter. Okay, so guys, first formula is that upthrust is equal to V rho G. VL means volume of the liquid displaced, rho L means density of the liquid, and G is the acceleration due to gravity. We can also find upthrust by the formula weight of a body in air minus weight of a body in water. Number 3, how do you find weight of a body in air? You can also find it by doing what? Mass into gravity. So mass of a body into gravity will give you weight of a body. Number 4, if you want to convert gram per centimeter cube into kg per meter cube, how do you convert? Multiply by 1000. If you want to convert other way around, then what you need to do? Divide by 1000. Okay, so this is the conversion. So there are some more formulas. So as we keep on solving the problems further, I'll keep on adding up the formulas. Okay, then second thing, okay, so let's start with the problems now. So right now, I think these many formulas are enough to do the problems of the A part of the chapter. So you will have to refer to the problems in your textbook, guys. We are going to do right now, you need to move to page number 110. Okay, we are doing sum number 1. I'll read out the problem for you. So the first problem is a body of volume 100 centimeter cube weighs 5 kgf in air and it is completely submerged. Underline the word completely submerged or immersed in your textbook. So what do you mean by completely immersed? Completely immersed means that whatever is the volume of the solid, that much volume of liquid will be displaced, which is 100 cm cube. Now what is the weight of the object in air? So weight of an object in air is equal to 5 kgf, that means 5 kilogram force. It is immersed in a liquid, so density of liquid is 1.8 into 10 raised to 3 kg per meter cube. So that means it is 1800 kg per meter cube. You have to calculate the upthrust and the weight of the body. So what are you asked to find now? Upthrust and the weight of a body in the liquid, which is also called as what? Apparent weight. Remember, WL is also called as what? Apparent weight. So we'll do one thing, guys. Out here, remember, I'll just write over here that this W over here. Okay. Or I'll just make another formula over here that the apparent weight of a body could be like weight of a body in water or weight of a body in liquid is equal to weight in air minus the upthrust. So actually, if you notice, formula number 2 and 5 is the same thing only. Just check that. Okay, so we need to find what, guys? First, we need to calculate first the upthrust. Now, how to find out the upthrust first? So we'll use the formula. Upthrust is equal to what? V rho G. Volume of liquid, density of liquid, and the gravity. Now see here, the catch in the problem is what? That your volume is in centimeter cube. Okay, volume is given in what? Centimeter cube. But the density is given in what? Kg per meter cube. So we'll have to convert either of them so that they both are in the same units. Now it is easier to convert kg per meter cube to gram per centimeter cube by just dividing by 1000. Rather than converting centimeter cube to meter cube, that's more complicated. Now Let's start solving. What's the volume of the liquid displaced? 100. What is the density of a liquid? 1.8 into gravity. So that is 180 GF, which is equal to 0.18 kgf. I hope you all got how. Divide by 1000 to convert GF into kgf. So we are done with the first part of the problem. What's the second part? Weight of the body in a liquid. So weight of that body in a liquid will be weight in air minus the upthrust. What's the weight of a body in air now? So it will be 5. What is the upthrust out here? 0.18. Subtract that, you'll get 4.82 kgf. So that's your answer. Okay, done. So yeah, this is very likely to come for your exams, guys. It can come for 3 marks in your exams. Problem number 2. So a body weighs 450 GF, 450 GF gram force in air. It weighs 310 GF when it is completely submerged in water. You have to first part find out what the volume of the body. That's the only difficult part, guys. And learn volume of the body properly. It'll come in many problems, and this is a place where you'll usually get stuck. So first we need to calculate what, we'll have to find out upthrust first to calculate all this. So I'll first do the third part. So upthrust is equal to weight of a body in air minus weight of a body in water. So weight of a body in air minus weight of body in water. So that's 450 minus 310. So be equal to 140 GF. I'll do the second part then. What's the second part? Loss in weight. So the loss in weight of a body is equal to what? Upthrust only, which is also equal to what? 140 GF. Now you need to find out what? Okay, now we need to do first part, sorry. So we'll find out the upthrust, the volume of a body now. So what's the formula of upthrust? Upthrust is equal to V rho G. Now, what was the volume of the liquid displaced or density of liquid? Not given. So it will be V only, right? What is the density of the liquid? It's water. So it will be 1 gram per centimeter cube. Gravity is not given. So you'll write what? G. Now very important. What is the upthrust? Okay. What is the upthrust? So upthrust is given to us as what? 140 GF. How to write 140 GF, guys, now? Look here. So we'll write 140 into G. Remember, whenever it is GF means what? Gravitational force is acting. So you have to put the gravity over there. Let's see, for example, 140 gram force basically means what? 140 into the gravitational force. This is what it means. Remember, make a note, very important. That's how we write. Now it's easy. You can just do the cancellations, cancel G and G. So therefore, volume is equal to what? 140 cm cube. But notice this is your VL, okay? This is your VL, but what if they asked us to find volume of the body? So we can write the statement that volume of a solid is equal to volume of liquid displaced is equal to 140 cm cube. What will be the reason? Because the body is completely submerged. So remember, whenever a body is completely submerged, always this will be applicable. Okay, so done. Again, this can come for 3 marks, guys. The same problem, 3 or 4 marks. Now next problem we'll do is the problem number 7. Okay, let's go to the problem number 7. It is a little similar problem, only 7th also. So guys, see, in the 7th problem, it's given that a piece of brass weighs 175 GF in air. So a piece of brass weighs 175 GF in air. Weight in air is equal to 175 GF. And 150 GF when fully immersed in water. So weight in water is equal to 150 GF. the density of water is 1 gram per centimeter cube. So, okay, I need to write rho, sorry. So density of liquid is equal to 1 gram per centimeter cube. What is the volume of the brass piece and why does a brass piece weigh less in water? So it's very obvious, it weighs less in water because of the upthrust. So we are done with the second part. Now what's the volume of the solid? So volume of the solid equal to volume of the liquid. Why? Because if you read the question, it's given that the body is completely submerged. Remember, if it was not completely submerged, Vs will not be equal to Vl. Okay, I think I'll leave this problem. You all can do it on your own. It's very similar to the problem number 2. First, we'll find what upthrust from this. Then use other upthrust formula, V rho G, and then calculate the volume. Okay, so I'm skipping the problem number 7. Then problem number 8. Now, what is the problem number 8? So a metal cube. So first of all, it's given that it's a cube of side 5 centimeter. So if the side is 5 centimeter, how much would be the volume of the solid? Equal to volume of liquid displaced is equal to side cube is equal to 5 cube is equal to 125 cm cube. Okay, then they say it has a density. Density of this solid is equal to 9 gram per centimeter cube. Then it's given that the density of the liquid. So see, out here it is not water, so the density is not 1. It's 1.2 gram per centimeter cube. Find the tension in the thread. And the gravity is also given to us. So gravity is equal to what? 10 meter per second squared. So see, everything was in CGS. It was all going so well. And then they gave you gravity, which is 10 meter per second squared. Now remember, whenever the gravity is not given to us, okay, if the gravity is not given to us, you can write your answers in gram force, okay, or kilogram force. But if the gravity is given to you, then you have no choice. You'll have to find the answer in SI unit only. Now what are we asked to find is you have to find out the tension in the stream. Tension here basically means what, apparent weight. And what do you mean apparent weight? Weight of a body in a liquid is equal to question mark. How do you find weight of a body in a liquid? Weight in air minus the upthrust. Weight in air minus what? Upthrust. So we need to first find weight in air, then you find out upthrust and then sorted. Okay, now one more thing, if you again check our formula list, okay, here we had written weight in air equal to mass into gravity, right? Formula number 3. Just one more formula. What is density equal to? Mass upon volume. Okay, again I need to write, sorry, I forget this again. Okay, so what is the mass equal to? Volume into density. So if I want to, what I'll do now, I will replace, look at this, I will replace this mass equal to V into rho here with M here. So this formula you can actually also simplify to what? V rho G again, but volume of solid, density of solid and into gravity, that's the difference. So weight in air is Vs rho S G, but FB is what? VL rho L G. Okay, now let's start the problem. So first part we'll calculate what? Upthrust. How do you calculate the upthrust? So use the formula V rho G, VL rho L G. Volume of liquid 125, density of liquid 1.2, gravity is G. Remember, we are not substituting gravity right now, that's a catch, because it is in SI unit and rest all in CGS. So we'll see later on what to do. Then weight of a body in water. How to find this now? So again Vs rho S G. What's the volume of the solid? 125. Okay, what is the density of the solid? 9 and into G. So when you multiply this, you will get 150 GF here and 125 into 9. So it will come 1125 GF, gram force. Remember, whenever it's into G, you just write gram force. Now, how will you find out the apparent weight? So, apparent weight is equal to what? Weight in air minus the upthrust. So, that's 1125 minus 150, which is equal to 975 GF. Now, 975 GF means 0.975 kilogram force, which can be written as what? 0.975 into gravity. And what is the gravity given to us? 10. So your answer will be 9.75 Newton. Okay, you may also learn directly that when gravity is 10, 1 kgf is equal to 10 Newton and directly convert it. But I wanted to make you understand, so I did the whole working. I think it's better if you do this whole working only because it's easier than to remember. Okay, next problem, number 9. Now, the problem number 9, it's given that a block of wood is floating on water with its dimension 50 by 50 by 50 inside water. Okay, underline inside water. So see, inside water means what? That's the volume of the liquid displaced. First thing, if you notice here, volume of solid is not going to be equal to the volume of liquid displaced because the full body is not submerged. First thing. Anyways, we don't need it also. What's the volume of the liquid displaced now? 50 centimeter by 50 centimeter by 50 centimeter. Here also given the gravity 9.8 Newton per kg. So, and it's given water. So the gravity is equal to 9.8 Newton per kg, which is as good as what? 9.8 meter per second squared. What is the density of a liquid? So since it's water, it's 1000 kg per meter cube. Okay. Now, what is the formula for volume? So it will be half into half into half is equal to 1/8 meter cube. Okay. So now we have everything ready. You have volume, you've got density, you've got gravity also. You just multiply all of them and you'll get the answer. So what formula are we going to use now? So we can use the formula. Okay, we'll use the formula what again? Upthrust is equal to V rho G. So upthrust is equal to V rho G. Volume is 1/8, density of liquid 1000, gravity is 9.8. Okay, it is 9.8. You'll multiply all of them and you get this answer 1225. 1225 Newton. Okay, then guys, next question. Okay, if you're wondering how to do these calculations, I'll show you these calculations also. Okay, look how to do these ones. So first we'll write what? 1/8 into 1000 into 98/10. Okay, cancel 0 and 0. Then we can cancel what? 2 4s are 249s are 4 1s are 425s are. So you just do now 25 into 49, or you can do what? Simply 25 into 50 minus 1. What is 25 into 50? 1250. What is 25 into 1? 25. So you get 1225 Newton as your answer. Done. Okay. Then next problem, number 10. Is now in the problem number 10, they say a body of mass 3.5 kg. So the mass of a body is 3.5 kg. Displaces 1000 cm cube of water when fully submerged. Again, so it's given that the body is fully immersed. So while it is fully immersed, what can we say? The volume of solid is equal to the volume of liquid is equal to 1000 cm cube. Now calculate the volume of the body. So how? Okay, fine. You already given then volume of a body, guys. This is actually our first answer. They are just asking you directly. So you don't have to solve for it. Just read the problem, write the answer. Second part is the upthrust on the body. Now it's given that it's water, so we'll have to assume the density ourselves. So what will be the density of the liquid? 1000 kg per meter cube, or 1 gram per centimeter cube. I don't know what unit we need. We'll take whatever you need. And calculate the upthrust on the body now. So guys, now we are doing the second part of the problem. So what is the second part now? That upthrust is equal to V rho G, volume of liquid, density of liquid into gravity. What's the volume of the liquid? 1000. What is the density of liquid? 1. Gravity is what? G. So 1000 GF. That's 1 kgf, 1 kilogram force. Okay, now if you multiply them, guys, look at this. If you multiply them now, what will you get? You'll get the answer for the when upthrust is done, you have to find the apparent weight. So for apparent weight, okay, guys, for apparent weight, what will you need first? The weight of a body. So first let's find the weight of a body in air, which will be what? Mass into gravity. So mass is how much? 3.5. Gravity is not given, into G. So 3.5 kgf. And now the last part comes, that is what? Apparent weight of a body. So apparent weight is equal to weight in air minus the upthrust. So 3.5 minus the upthrust. So that is 2.5 kgf. Okay. So yeah, guys, done. You can also try sum number 4. Okay. Guys, you can try sum number 4 on your own. You'll be able to do that problem. Okay, now the next I'm doing is we'll do the problems which are of the B part of the chapter. So we'll add up some more formulas now in the same formula sheet that we were using earlier. So we already have the formula for density. Now guys, the next formula that we are using here, the 7th formula, is RD of a substance. Now what do you mean by RD? RD means what? Relative density. So relative density is defined as what? Density of a substance. Density of a substance divided by density of water at 4 degrees centigrade. What is the density of water at 4 degrees centigrade? It's either 1 gram per centimeter cube or 1000 kg per meter cube. You will choose the value depending upon the other data. Okay. So if your density of substance is in CGS, you'll write 1. If it's in SI, you'll write 1000. Okay. Next formula is the RD of solid. RD of solid. What is the RD of solid now? It is found by weight in air upon weight in air minus the weight in water. Okay. Then 9th one is the RD of liquid. What is the RD of liquid now? So weight of a body in air minus weight of a body in liquid upon weight in air minus weight in water. So remember, formula number 7 can be used for anything, either for solid or for liquid. But obviously 8th can be used for only solid and 9th can be used for only liquid. Okay. Then guys, now another thing, they can also ask you about, okay, what is the unit of RD? So if you remember, RD has got no unit. Okay, RD has got no unit. Why? Because it's a pure ratio, that's why. Then the formula which you need for the C part, I'll show you the C part formula also right now only. That is also simple, guys. So now the formula number 10. You see in the formula number 10 now, you are given, let's say we are given that there is an ice cube there's an iceberg which is floating. So when an iceberg is floating now, remember 90% of the iceberg, as we know, is inside the water and 10% is above. But when a block of wood is floating, it will not float the same way. It will float in some other proportion. Maybe 70% is outside and 30% is inside. When rubber will float, say 40% is outside, 60% is inside. So how do you find how much is inside and outside? So for that, I'll tell you another formula now, which you have for that. Now see, first now look at these notations. Let's say the volume which is submerged. Okay, the volume which is submerged, meaning which is below the surface of water, let it be represented by small v. Okay, that is small v. The full volume, okay, the volume of the whole thing, full of the iceberg, let it be equal to what? Capital V. So small v means what? Volume submerged. Capital V means what? Total volume. Then we have got this another symbol rho s, means density of a solid, and rho L is what? Density of the liquid. So there is liquid out here, like for example water. Let its density be what? Rho L. Now what is the formula in this one? The formula we use out here is small v upon capital V is equal to rho S upon rho L. Okay, how do we get this formula? If you want to know the derivation, look here, it's very simple. See, we know that while floating, okay, while an object is floating, its upthrust has to be equal to what? Weight of a body in air. Then only it can float, right? What is the formula for upthrust? So we'll write V rho G. VL rho L G. What's the formula for weight of an object in air? So volume of a solid, density of a solid into gravity. Can we cancel anything out here? Yes, we can cancel what? We can cancel the gravity and gravity here. But you notice now, what is the volume of the liquid displaced? So volume of a liquid displaced is actually equal to what? The volume which is submerged. Right? Rho L is as it is. Rho L. What is the volume of the solid? So volume of the solid is equal to the total volume. And what is the density of the solid? It is rho S only. If I cross multiply, I'll get small v upon capital V is equal to rho S upon rho L. So how much portion of a body will float above or below? It all depends upon the ratio of the density. Density of the solid and the density of the liquid. Okay, you can also make a note. If you're getting confused, just make a note that what do you mean by small v? Small v means what? Volume of the solid which is submerged. Okay, only that part of volume which is submerged. And what do you mean by capital V? The volume which is above. Or we can say, sorry, not volume above, the total volume of the substance. So we'll write here total volume of the substance or of the ice out here. Okay, so in the C part, you actually have got only the one formula. I'll do one thing, guys. We'll do first C part problems. Okay, so guys, in the C part problems are very easy, guys. So I'm doing those ones first. Okay, let's begin now with the C part problems. So again, guys, you'll have to go to page number 124. Page number 124. Okay, first numerical. Here also, guys, we are not going to do all the numericals. I'll show you the few which are important from your exam point of view. So the first sum now, let's start with the first numerical. A rubber ball floats on water with its 1/3 volume outside water. So 1/3 volume is what, guys? Outside water. So underline the word outside. 1/3 volume is outside water. So therefore 2/3 volume will be what? Inside water, correct? 1/3 is outside, so 2/3 will be inside. What is the density of the rubber? Now they're asking you what is the density of a solid. Density of the liquid is not given. We will assume it as what? 1000 kg per meter cube because it's water. Now let's start. So first, when they say 2/3 volume is inside water, what does it mean? So what do you do? Let total volume be equal to what? 3 cm cube. You'll understand now why I took 3 cm cube, because then he's saying the volume which is submerged is just 2/3 of the total volume. And what is 2/3 of total volume? Is equal to 2 cm cube. Okay, those who find it easier, they can directly take the ratio of small v upon capital V, directly 2/3. See, from here also actually you can make out that small v upon capital V is what? 2/3. Okay, look, from this statement only you can make out. Now let's start the problem. So small v upon capital V is equal to rho s upon rho L. Small v is 2, capital V is 3, rho s is how much? We don't know, and rho L is how much? 1000. Cross multiply, you will get 2000 upon 3, and that's 666.666. Okay, but you can't write 2 3 decimal place. You'll have to write it as 666.67 kg per meter cube. Okay, so change the answer in the textbook. The answer is given wrong in the textbook, guys. Okay, problem number 2. A block of wood. So you have got a block of wood whose mass is equal to 24 kg and its volume is equal to 0.032 meter cube. Find the volume of block below the surface of water. So first there is water, so rho s is equal to it's water, so we'll write what? Rho L is equal to 1000 kg per meter cube. Then find the volume of block below the surface of water. So small v is question mark, and what is the density of the solid, that is the wood. So we'll solve first for the density of solid, that is mass upon volume. Mass is 24, volume is how much? 0.032. So that's 24 into 1000 upon 32. 8 3s are 8 4s are 4 1s are 250s are. So it will be how much? 750. It will be 750 kg per meter cube. Okay, now we have to also calculate what? Small v. How to calculate the small v? So small v upon capital V is equal to rho s upon rho L formula. Let's start substituting now. What is small v? We don't know. Capital V is 0.032. What's the density of solid? 750. What is the density of liquid? 1000. Now cross multiply. First, what is 750 upon 1000? In fraction it will become what? 3/4. And 0.032 will go on the other side. Now what does this become? So 3 into 40 point it'll come 0.8, right? So it'll be 0.24. This will be 0.08. So answer will be 0.024 meter cube. So that's the volume of the solid which will be submerged. Then guys, next problem is the problem number 4 I'm doing. So in the problem number 4, a piece of wax floats on brine. So if you all know what is brine, it's like the salt water or saline water basically. What fraction of its volume is submerged? Read the question properly. They are asking you what fraction of what fraction of its volume is submerged. So small v is how much? Or you can say what is the ratio of small v upon capital V? How much volume of the total is submerged? So this is also quite simple problem. First, you are given density of a solid, density of a liquid. What is the density of solid? So it's 0.95 gram per centimeter cube. What's the density of liquid? 1.1 gram per centimeter cube. Now, what is small v upon capital V is equal to rho s upon rho L. What is rho s? 0.95. What is rho L? 1.10. Small v upon capital V. Now guys, when you solve it further, okay, look here. When we are solving it further, now what will we get? So out here, what can I say now? That small v upon capital V is equal to 95 upon 110. 5 19s are 5 22s are. It means the volume which is submerged is 19 upon 22 of the total volume, guys. This is your final answer. They have written the answer in decimal. Okay, but you can leave it in fraction because in fact they have asked you to do it in fraction. Guys, same way you will do problem number 5. Okay, same way. It's a very same problem, very similar problem, only the densities are different. Then guys, after the 5th problem, we will do problem number 7 now. Okay guys, problem number 7. A wooden block floats in water with 2/3 of its volume submerged. So you've got a wooden block which is floating how? In such a way that 2/3 of it is submerged inside. Small v upon capital V is 2/3. And this is how it is floating in water. So the density of water is equal to 1000 kg per meter cube. So we don't know the density of the solid, that is wood out here. I think you all can find it yourself now. So how will you find it? Small v upon capital V is equal to rho s upon rho L. So 2/3 is equal to rho s upon 1000. So rho s is equal to 2000 upon 3, which is equal to 666.67. Okay, on rounding off and all, kg per meter cube. Now guys, we have to also write what now? We have to do the second part. There is one more part to the problem. Now what is the second part? So then okay, so now guys, in the second part they are saying when the same block is placed in oil, 3/4 of its volume is immersed in oil. So how much volume is immersed first of all? 3/4. So small v upon capital V is 3/4. Quarter means what? 4. 3 upon 4. Density of oil is question mark. Density of solid is given as 2000 upon 3. Okay, do not use the decimal value. Remember, use this fraction value. It will be easy for you to solve further. What's the problem? Small v upon capital V is equal to rho s upon rho L. So small v upon capital V is equal to rho s. What is rho s? 2000 upon 3. What is rho L? We do not know. So cross multiply, you will get 8000 upon 9. So that will be how much? 9 8s are 72. 80 remainder. 9 8s are 72. 888.8888. So you round it off to what? 888.89 kg per meter cube. Guys, change the answer in the textbook. You'll have to change both the answers, first and second part. Okay. Then next problem, number 8. In the problem number 8, the problem is easy, only the calculations are tougher in this problem. So guys, you're given that the density of a solid, that is ice, is given as 0.92 gram per centimeter cube. Then you're given the density of a liquid is 1.025 gram per centimeter cube. But when you solve the problem with this value, it comes very difficult, the calculations. So only for a convenience, only in the class. Okay, you cannot do this in exam, guys. I'll repeat. You cannot do this in exam. Only for a convenience right now, I have changed the value 1 to 1.15 gram per centimeter cube. And I hope they may give you easy calculations in the exam also. Now they're asking us find the total volume of an iceberg which floats with its volume above water. So total volume of iceberg is how much if it floats with 800 cm cube above water. So first what we'll do, let the small v, let the volume submerged be equal to x. So what will be a total volume? It will be volume submerged plus the volume which is above. See, I'll just explain you graphic with the diagram. What does it mean? We have assumed x is inside and how much is outside? 800. So what's the total volume? X plus 800. Now it's a very simple problem. Sorry. So now rho s upon rho l is equal to small v upon capital V. So substitute, what is rho s? 0.92, rho l 1.15, small v is x, yeah, so you cross multiply and you'll get the answer. Your x should come to 4,000. It should come to 4,000 centimeter cube as your answer. Okay. Yeah. So these are the types of problem for the C part. I'll show you now some for the B part. Let's see. In the B part also some of the problems are just formula based only. So see first problem number, we'll start with the 10th one. One of the simplest problem. In the 10th one, it's given a solid weighs 120 gf in air. So weight in air is how much? 120 gf. 105 gf when completely submerged in water. WW 105 gf. What will be the RD of solid? So what's the formula for RD of solid? So RD of solid is equal to what? If you'll recollect guys, weight in air upon weight in air minus the weight in water. What is the weight in air? 120 upon 120 minus 105. So 120 upon 15, which is equal to 8. Done. And there is no unit for RD. Guys, there is a sum number 12, exactly same type of a sum. You will do it on your own. Okay. Then problem number 14. How to do the 14th problem now. So in the 14th problem, it's given a jeweler claims that he makes ornaments of pure gold of RD 19.3. So RD of pure gold is how much? 19.3. Then he sells a bangle which weighs 25.25 gf to a person. So the weight of a bangle is 25.25 gf. Then the clever customer weighs the bangle when immersed in water and finds that it weighs 23.075 gf. Guys, weight in water is equal to 23.075 gf. Guys, now see, generally when you buy all these ornaments and all, we don't go home and again check the weight in water. But you see in the question they have given the customer is clever. So underline that very important line, the clever customer. So what did this clever customer do? He went home, he checked the weight in water, and then he's doing what, he's finding out now the RD of a bangle that he's bought. So what's the RD of that bangle now? Again, same formula, weight in air upon weight in air minus weight in water. What's the weight in air? So 25.25 upon 25.25 minus 23.075. So that becomes what? 25.25 upon something. Do all these calculations, guys. Your calculations will come quite tough in this. That's why I have marked this problem as DC. You can check in your textbook. I marked it as DC, difficult calculation. Okay, I'm writing the answer right now directly, 11.6. Guys, is this bangle made up of pure gold? Obviously not. So why is it not made up of pure gold? Because it is because the RDs are not same. You can see RD of gold is 19.3 and your ornament is 11.6. So it's a fraud. They are not giving you the pure gold. So what our conclusion is that it's an impure gold. Then guys, now next problem, we'll do problem number 16. Okay, in the 16th problem now, it's given that a piece of stone of mass 15.1 gram. So the mass of stone is 15.1 gram. First immersed in a liquid, and it weighs how much? 10.9 GF. So 10.9 GF. Okay, I made a mistake in writing this. It is immersed in a liquid and it is 10.9 GF, and again then you check its weight in water and it comes to how much? 9.7 GF. Okay, now the first part of the question. The first part they're asking us is, again guys, it's in water, right? So I'll just write down the density of water also. So the density of water is 1 gram per centimeter cube. Okay, now let's begin the first part of the question. A part. What are they asking us in the A part? The weight of the piece of stone in air. So how do you find the weight of an object in air? Mass into gravity. So it's 15.1 into gravity. So 15.1 GF, gram force. Done. Now B part. What's the B part of the problem? Volume of the piece of stone. Now how do you find the volume of the stone? So first we'll have to calculate what? Upthrust. So first we'll calculate the upthrust, which is equal to what? Weight in air minus the weight in water. Weight in air is how much? We found 15.1. Weight in water is 9.7. Subtracted. So 11 minus 7 is 4. 14 minus 9 is 5. 5.4 GF. Okay. So done. No, sorry. We are not done. We only found the upthrust. So now we have to calculate what again? Upthrust is equal to V rho G. Volume of the liquid, density of the liquid into gravity. So instead of liquid now guys, what I'll do, since they have already mentioned another liquid, I will not use the word liquid here. I will write here W. Volume of the water displaced, density of the water. Now what is the volume of thrust equal to? 5.4 GF, which also means 5.4 into G. Volume of the water displaced. What's the volume of the water displaced? We don't know. That will be same as the volume of solid. Density of water is 1. Gravity is G. Guys, can we cancel anything out here? Yes, we can cancel G and G. And what will you get now? The volume of the solid, which is also equal to the volume of the water displaced, which is equal to 5.4 cm cube. That's the answer. Now, so B part was long. Yeah. Now the C part, guys. RD of stone and the RD of liquid. So guys, I think C part and D part you can do on your own. What formula will you use for C part? RD of liquid is stone is equal to what? WA upon WA minus WW. How will you find out the RD of liquid? WA minus WL upon WA minus WW. Okay, so that was the problem number 16. There are some more problems, guys, which you can try on your own. You can try the problem number 3, then you can try problem number 4. You may try 6 also, not that tough. And then maybe 8th one. 8 is a little tougher, guys. You can try still. And then just try these problems, guys. Extra problems other than that. Okay, I think these many should be enough mostly for your school exams and all.